We are moving on right along to Lesson 2, Operations of Arithmetic. Here's your objective. Learn and apply the properties of arithmetic and the relationships between them. Let's go ahead and move on to your fun fact of the day. Fun fact of the day today is that your tongue is the only muscle in your body that is attached at only one end, because it's attached in your mouth and then not attached over on this end. Every other muscle, biceps, triceps, abs, doesn't matter. They're all attached on each end. Alright, let's go ahead and get started with the math. Example 1 here says, what is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? Okay, well, we've talked about words like quotient and product and sum. Okay, so we want to know what is the quotient. That means what is the answer to a division problem. So I'm going to write it with a fraction bar because we know that means divide. And I want to know when the product of 3 and 6, so that means 3 times 6, is divided by the sum of 3 and 6, which means add 3 and 6. Okay? So what is the quotient, the answer to a division problem, when the product of 3 and 6, a multiplication problem, is divided by the sum of 3 and 6? And divided by means this part right here has to go on the bottom. Well, we talked about PEMDAS, order of operations, already, so we know we're going to do the top. 3 times 6 is 18. Keep our division bar. 3 plus 6 is 9. That answer is 2. Easy enough. Alright, let's go ahead and move on to to some of the properties that you will have to know for the rest of the lesson. Alright, and here are some properties of arithmetic that you need to know. Okay? First one is called the commutative property. The commutative property works for multiplication or addition. Okay? So I've illustrated that here with a picture. A football plus a basketball is the same as a basketball plus a football, because either way I've got one football and one basketball. Okay, no matter how I decide to put them together. Multiplying works the same way, so here's a picture to illustrate that. Alright, in math terms, that means that a number plus a different number is the same as the second number plus the first number, so it doesn't matter what order I add numbers in, I should get the same answer. 1 plus 2 is 3, 2 plus 1 is 3. Okay, same thing with multiplying. 1 times 2 is 2, 2 times 1 is 2. So I can multiply numbers in any order and still get the same answer. That's what the commutative property says. You will need to know commutative property. Okay, in algebra terms, we're saying that any number plus any other number is equal to the second number plus the first number. So a plus b equals b plus a is how we represent that in math terms, okay, in algebra terms. So, see all these picture spots here? I'm going to want you to draw your own little pictures in there, such as I did with the footballs and the basketballs there to represent each one. Okay, second one is the associative property. The associative property works for addition and multiplication. What the associative property says is that it doesn't matter how I add numbers together, which ones I do first. Okay, I should still get the same answer. So for example, the order of operations, PEMDAS, says that here I should add 2 plus 3 first. Well, 2 plus 3 is 5, and then 5 plus 1 is 6. Over here, PEMDAS says I should add 1 plus 2 first. 1 plus 2 is 3, and then 3 plus 3 is still 6. Okay, so it doesn't matter what order I do those in. I still get the same answer. Multiplying is the same thing. Okay, now in algebra terms, we say that A plus, we say B plus C is equal to, and then parentheses, A plus B plus C. Okay, sorry, I ran out of room there. You guys try to squeeze that in. Okay, so the same thing here. Associative is A times any other two numbers, B times C, if I do these two numbers in the group first, is equal to multiplying A times B first, and then multiplying by C afterwards. Okay? So that's what the associative property is if I take B plus C and then add A to it, okay, I still get the same thing if I add the first two parts first. Alright, identity of addition. What the identity of addition says is that if I take any number, so we'll pick 1. Actually, no, I don't want to pick 1. Let's erase that. Okay? Let's pick 2. And I add 0 to it, I get the same number that I started with, 2. Okay, that's called the identity of addition. Anything plus 0 is itself. So again, in algebra terms, that would be any number plus 0 equals itself. Okay, so if I was drawing a picture for that, I might put like a star plus 0 equals a star. Okay, you can put whatever you want in there for a drawing, but I do want drawings to represent this in some way. Okay, identity of multiplication. Well, the identity of multiplication is how do I start with a number and multiply it by something and still get itself. See, the identity of addition said I start with a number, what do I add to it to keep itself? Because that's what identity means, is yourself. Well, I had to add 0. Okay, so I start with a number, add 0, I get itself. Well, in multiplying, if I start with a number, how do I end up with itself? Well, I've got to multiply it by 1. 2 times 1 is itself. 3 times 1 is itself. So the identity of multiplication says that any number times 1 equals itself. Right, and then there's the 0 property of multiplication. The 0 property of multiplication says that any number times 0 equals 0. Okay, any number times 0 equals 0. So again, any number times 0 equals 0. That's called the 0 property of multiplication. So again, quick review here. We have commutative property of addition, commutative property of multiplication. We also have associative property of addition and multiplication. We have identity of addition, any number plus 0 equals itself. Identity of multiplication, any number times 1 equals itself. And the 0 property of multiplication, any number times 0 equals 0. Okay, let's apply these here. We're going to do what's called justifying. Okay, some steps, which means kind of prove it using these properties. That's on the next slide. Okay, example 2 says to show 2 ways to simplify this expression and justify each step. Okay, well, here's the expression. One thing I could do is just to follow PEMDAS and multiply it on down. Okay, so I could start by doing 25 times 15. Okay, and I'm going to get my calculator here quick, so I don't have to write that out. I could just do 25 times 15, and that's 375. Okay, justify each step means tell me why I'm able to do that. Well, I know that that's parentheses. Okay, and I always do parentheses first. Okay, sorry about that. There should be parentheses. Let's go ahead and erase it. Parentheses. Okay. Well then, I know that I can just do 375 times 4, and that's 1,500. Okay, and that's just multiplying. So justify each step means pretty much just tell me what you did. Okay, I did the parentheses or why I was able to do something. So I did the parentheses first because that's what PEMDAS says, and then I just multiplied what's left. Okay, and that's fine and dandy if you have a calculator. But let's say you didn't have a calculator and you needed to quickly compute this. Okay, or you wanted to do it faster than a calculator could. Well, we can arrange these numbers in a different way to make this a mental math problem. Okay, and here's what I mean by that. Okay, so I'm looking at these three numbers going, I'm multiplying all these, and I know that 25 times 4, that's pretty easy to do. Okay, but parentheses always have to come first, right? But we just learned some properties where we can kind of rotate things or switch things. So watch this. One thing that I can do is flip-flop these numbers so the 25 and the 4 end up being right next to each other. And I still can't change the parentheses because I can only do one thing at once. So I'm going to leave the parentheses in their same spot, which means they're going to go around the same two numbers. And I'm just going to flip them. And do you see what happens here? I still can't do 25 times 4 yet, but they're at least right next to each other, so they're a little closer. Okay, which means we can do one more thing of adjusting to get them right next to each other. Well, do you remember what property said that I can multiply two numbers in any order? That 25 times 15 is the same as 15 times 25? That was the commutative property of multiplication. So I'm just going to abbreviate that. Again, that's part of justifying my step. The commutative property of multiplication says I can switch these two around, and that would still be the same answer. And again, the reason I want to do that is because I'm looking going, okay, I know 25 times 4 is really easy. That's 100. And that's going to make this a mental math problem. Alright? But I still have this problem of parentheses here. Well, there's also a property that says I can group things together for multiplication in whatever order I want to, which means if I do 15 times 25 first and then multiply it by 4, that's the same as if I did 25 times 4 first and then multiplied it by 15. So what I'm going to do is this. I'm going to move these parentheses around the 25 times 4. And if you look at your list of properties from the previous example, you should realize that that looks like the associative property of multiplication that says that I can switch the parentheses around if it's all multiplying. Okay, so that way I can group these two together. Well, now if I do PEMDAS, okay, I know I'm doing 25 times 4 first. Well, so that's 15 times 25 times 4, that's 100. Okay, and that time I just did the parentheses again. Sorry, I ran out of room there. Parentheses. And I'm going to go ahead and multiply and finish the problem. And my last step is multiplying. Okay, so I did the commutative property, switch these around. I did the associative property, move the parentheses around the numbers I wanted to multiply first, and then I went ahead and multiplied. Now again, this really what I'm doing here, this process, is making this a mental math problem. I'm saying that I understand, because of these two mathematical properties, that I can multiply 25 times 4 first and get 100, and then multiply that by 1500. Or sorry, multiply that by 15 and get 1500. And that is a heck of a lot easier to do in my head than trying to figure out what 25 times 15 is and then multiplying it by 4. Okay? So that's what these properties are good for. Okay? Now your job is to recognize them and to be able to justify or prove why I'm able to rearrange things into a mental math problem. Alright? Well, we'll conclude our lesson here. Sorry, whoops, we'll move this up here. Okay? So, keep calm, ask any questions you got, and happy homeworking.